Hello, welcome back to EEforEveryone and part 9 of the Plant Light project series. Today we're going to assemble the power board. This PCB is a little tricky to assemble. There are a few components that require a really steady hand, some components with thermal pads requiring a hot air soldering method. There are also some components that I've had issues with solder not wetting to the pads due to corrosion. This video is trying to capture nearly 4 hours of soldering, and many of these components require a slightly different method. This isn't meant to be a soldering tutorial, but we'll discuss some of what was done during the time lapse. This video is meant to be awesome and show off some of the work, the labor of love, that goes into each and every one of these plant lights. Without further ado, let's warm up the hot air gun and let's get soldering. We are starting out with the LEDs. I have mixed feelings about how soldering these to the PCB went. The first time I attempted to assemble this board, I was using solder paste and the hot air gun, and I simply could not get all 3 pads to stick to the board at the same time, because I couldn't get solder to wet to the pads. After a few hours of frustration, I said, and I quote, "Screw it. Even if I do it wrong, at least I will have a board assembled." And that's what you're looking at here. Me doing it wrong. In order to ensure solder wets all the pads of each LED, I first tin the surface mount pads of the part and then reflow them on the PCB with the hot air gun, applying flux underneath each LED. This helps the solder get to where we need it to go. This isn't an ideal process by any means, and it ended up being the most tedious part of the whole assembly process. If I were to design this lamp again, I would either look to have it assembled on a proper SMT line, pick LEDs that wouldn't be such a pain to solder to the board by hand, or at the very least, add 0603 pads by each LED for testing to ensure each LED is soldered correctly. The LED drivers all have thermal pads and fine-pitch gull-wing leads. This combination is a little tricky, but I ended up tinning the thermal pad, reflowing the part onto the board with the hot air gun, aligning the fine-pitch leads with tweezers before removing the heat, and then following up with the soldering iron to finish the fine-pitch leads. I made a couple solder bridges while doing this, and I still haven't bought any solder wick. I used a piece of scrap stranded wire and some of my paste flux as a substitute for proper solder wick. I should really buy some solder wick. The other components are all relatively easy to install. The inductors, 0603 resistors, and capacitors, the SOT23 packages, they're all pretty easy to manage if you can make it past the LED drivers and the LEDs. That's actually a big part of why I assemble those parts first. If I were to populate all of the surrounding parts and then damage the PCB while assembling the tricky parts in a less than ideal way, I'd really be having a bad day. That's why I chose to assemble the boards in the order starting with the components that I'm least comfortable soldering and ending with the components that I am most comfortable soldering. There are a lot of great tutorials for soldering surface mount parts online. I encourage you to check them out. I find that using surface mount parts saves me time because I don't need to spend as much time bending leads, cutting leads, or flipping the board over a million times. I'll admit it took some learning, but you can get a 2-layer PCB for so cheap these days. We could order a few boards with a ton of practice pads and just go to town soldering different surface mount components to the board. Then again, I've been smelling a concerning burning smell from my soldering iron after it was on a while during this time lapse. Maybe it's time for a new one. When I get a new iron, we can test it out and create a soldering tutorial at the same time. Sounds like a win-win to me. Now we have our power board with all the components installed. It looks great. In the coming videos, we'll evaluate the performance of this plant light project design in a variety of ways. We will design an enclosure to hold this project together and make some tweaks to the hardware and software that bring this light closer to the requirements we defined in part 1 of this series. If you think that soldering is cool and this video is great, let me know by hitting the like button on this video, subscribing to the channel, and leaving a comment letting us know what you enjoyed. Most of all, I hope that you learned something great today, and I hope to see you again soon. Bye!